Hey everyone, today I'm going to solve spiral matrix version 4. You are given two integers m and n which represent the dimension of a matrix. You are also given the head of a linked list of integers. Generate an m by n matrix that contains the integers and linked list presented in a spiral order which is clockwise starting from the top left of the matrix. If there are remaining empty spaces, fill them with -1. Return the generated matrix. So let's take the first example. So how many nodes, how many rows we have? We have 3 rows, right? And how many columns we have? We have 5 columns, right? And the head of the linked list is gonna be this one, right? The head is, I mean, the head of the linked list is gonna be this one, right? We have this linked list. So the first thing what we're going to do is we're going to create a matrix, right? So let's create a matrix with 3 rows and 5 columns. So this is going to be our matrix. We're gonna have how many rows we have, how many columns we have, 5 columns, right? Let's count them, 2, 3, and it's gonna be the fifth row, right? The fifth column, and we're gonna have how many we have 3 rows, right? And what the first thing what we need to have is pointers, right? To solve this problem, what we are going to have is what we are going to need is just pointers, right? This I have the first thing, yeah, we need to have 4 pointers. Let's say the first point is gonna be left and the next one is gonna be top, and we're gonna have the right pointer here, and we need to have a bottom pointer here, right? So the first direction we are going to traverse is from left to right. So we need to traverse in this direction, right? So in when we traverse from left to right, this we're going to start from the first mode, right? Since we have to start from in this cell, so the first node we have is just with node with 3, right? What value is gonna be 3? So we have to fill the top left corner with value 3, right? So its value is gonna be 3. And the next node is gonna be this one, right? So the next cell is gonna be with value 3. And we have node with 2, and it's gonna be this is going to be 2, and next one is gonna be 6, and the last one in this direction is gonna be 8, right? So it's gonna be 8. So once we have done traversing from left to right, the top pointer should move to one step downward, because we have already traversed the row which the top pointer is going to point, right? Was initially pointing, right? So once we are done traversing left to right, then we have to traverse to top to bottom, right? In this direction, as you can see. Then the next node we have is just node with value 1, right? So then this is going to be 1, and the next one is gonna be 7, and it's gonna be 7 here. And once we have traversing this, then our right pointer has to move to this direction, this point, right? Then the next direction is gonna be moving from right to left. Then the node we are now is going to be 9, right? Then this is going to be changed to 9, and the next one is gonna be 4, right? It's going to be 4 here, and the next one is gonna be 2, and we have to change it to 2, and the last is gonna be 5 in moving in this direction, right? Then once we have done moving in this direction, we have to move our bottom to one step up, right? Because we have already traversed it, which was initially pointing, right? Then once we have to traversing from right to left, we have to traverse from bottom to top, right? In this direction. Then the cell we are going to traverse in from bottom to top is gonna be this cell, and its value is gonna be 5. And as you can see, we are here, and the last node is gonna be 5. And since we are traversing, the next traversal is gonna be starting again. We start traversing left to right. Then the cell is gonna we have to traverse is gonna be this one, and this value is gonna be 0. And since we are done, we have taken all of the nodes from the linked list. The rest of the sales value is gonna be -1, right? This is going to be -1, and this is going to be -1, right? And the left pointer should move to this direction, right? Because we have already taken the column which the left pointer was pointing, right? So the time complexity solving in this way is gonna be the number of rows times the number of columns, right? And the space complexity is gonna be only O of 1, because we are not going to consider the space we are going to use to output the answer, right? So I'm going to solve this problem. So let's go to the implementation. Well, the first thing what we are going to do is we need to have the left pointer and the top pointer, right? And both of them are going to be. We can start from top is gonna be, both of them is going to be 0, right? And the right pointer and the right is going to be, and we're gonna have a top, bottom, let's say bottom. The right pointer is gonna be the number of columns -1, and the bottom pointer is gonna be the number of rows -1, right? So while the left is less than or equal to the right, and the top is less than, if the top is less than or equal to the bottom. And what we're going to do is we need to have a direction. So we have to check the direction, right? We have to know in which direction we are traversing, right? So if direction is 0, let's call the first direction from, call it 0, right? If it is 0, we have to traverse from we have to traverse from left to right, right? So for let's say I in range of left, we start from the left and we traverse till the right. So, and what we're going to do is let's create first, before moving, we have to create a matrix, right? Let's call our matrix just matrix, and its value initially is getting -1 for just, let's say, 4 is gonna be the number of columns. Yeah, n is gonna be the number of columns, and for then for in range of the number of rows, we have to create a matrix like this one, right? And once we have done creating, then what we are going to do is, since now we are traversing the top point, I mean the row which the top pointer is pointing. So the row is gonna be like the matrix at the row. I mean top. The row is gonna be the top, and the column is gonna be this I, right? And it's gonna be and we need to have also current is pointing the head of the linked list, right? And current dot val if current, right? If current is not none, it's gonna be current dot val. Otherwise, it's gonna be -1, right? And we have to, then once we have done this, we have to current is gonna be current dot next, right? If current, else current is gonna be none, right? Then the next direction is gonna be direction with the next direction is gonna be 1, right? Let's call it 1. If the direction is 1, let's call it when we traverse from top to bottom, let's call it direction 1. Then if it is direction 1, for let's say I in range of top, we have to traverse to bottom, right? Yeah, bottom +1. Then matrix. Then what we have going to fix is the right. So the right is gonna be just a column, right? So I is gonna be a row, since we are traversing the row, and the right is gonna be a column. So char dot val if char otherwise it's gonna be -1. And cur is gonna be cur dot next if cur, otherwise it's gonna be none, right? And the other one is gonna be just let's call the third direction is just traversing from right to left. Let's call it 2. And for I, let's say in range of we are traversing right from we start from the right and we traverse to the left and we decrease since we are decreasing by 1. Then matrix we are going to fix the bottom, right? The bottom is gonna be our row and just we are traversing the columns. So it's going to be a column, then dot val if our current is not none, otherwise we have to assign it with -1. And current is gonna be cur dot next if cur, otherwise it's gonna be none, right? Our current is gonna be none. And the last direction we have to traverse is gonna be just the third, the fourth direction is gonna be we don't need to assign it. They say we are just if it is not either of these directions, we have the last direction, right? So the last direction is just moving from bottom to top, right? So let's say in range of we are traversing from bottom, we are traversing bottom to top, right? And we decrement by 1 and matrix at since we are moving through the rows, the cut is gonna be a row and left is gonna be just our column, right? Left, then car dot val if car, otherwise it's gonna be -1. And car is just car dot next if our current is not none, otherwise we have to make it none. And after doing this one, what we are going to do is we have to check our direction, right? I mean, we have to, for example, if we are at the last direction, we have to start from the first direction because we have to start again, right? So to make that, we have to since we have four directions, we have to mode it by 4. For example, if I am at the third direction, when we add 1, it's gonna be 4. 4 more by 1 is gonna be 0. So I'm going to start from the 0 direction. So we'll start from again from the first direction. So the next thing what we are going to do is we are going to return the matrix. So guys, if let's see if this gonna work, if it works or not. So there is unmatched somewhere unmatched thing. Okay, we have to change. We have to remove this one, right? Okay, then there is something also we need to check if this is the case. If instead of else, it's gonna be else if, right? That's my bad. We have to do yes. Yeah, this one is it's just then the time complete is gonna be just the number of time is just time is just of m times n, the number of rows times the number of columns, and just okay, and okay, it says then okay. So one thing we don't need to forget is just we have to shrink the top right once traverse this one, and once traversing the right have to move decrease by 1, and in the third direction the bottom has to decrease by 1. In the last direction the left has to move from left to right by 1 step. So the time is just the number of rows times the number of columns, and the space is gonna be of 1, right? As you can see, it passed for the 2 test cases. So space is just of 1 because we didn't use any extra space, but we have only used this space to return our answer, right? So let's submit it, right? So as you can see, passed for all of these cases. If you like this video, please subscribe and share the people who you know. Thank you very much.